Hello, calculus fans. Okay, so let's use Newton's method. We're going to estimate a root of the equation x equals e to the negative x squared. We're going to use the initial guess, x1 equals 0.5, and we'll perform two iterations of the algorithm. That means since we're starting with x1, one iteration will get us to x2, another iteration will get us to x3. So we'll rewrite the equation by putting everything to one side. So we'll have x minus e to the minus x squared is equal to 0. And then we'll define a function f of x equals x minus e to the minus x squared. We'll need to compute a derivative in order to use Newton's method. So we have to differentiate the function f of x. And so when we do that, we get f prime of x equals 1 plus 2x e to the minus x squared, using the chain rule. Okay, so now we can plug everything into the formulas for Newton's method. So the general formula is x sub n plus 1 equals x sub n minus f of xn over f prime of xn. And now we'll plug in the function and its derivative into this to get a specific formula for this case. Okay, so it's going to be x sub n plus 1 equals x sub n minus, and now on the top and the bottom we've plugged in the functions for f and f prime, and we've plugged xn into those. So the top will be xn minus e to the minus xn squared. The bottom is 1 plus 2x sub n e to the minus xn squared. So let's plug in our initial value. So we were given in the problem to choose x1 equals 0.5, and let's plug that in now. So when we start, n is equal to 1, because that's the first iteration. So we get this formula here, and we'll plug in 0.5 in place of x1. So if we do that, we get this expression, and then we work all this out on a calculator, and what we get is about 0.65673. So what we'll do now is, since this is our value of x2, we're going to run one more iteration. And one more iteration should, we hope, get us closer to the actual root of the equation. So we now have that x3 is equal to x2 minus f of x2 over f prime of x2. And then we've gone ahead and just written it out here, what the f of x2 and f prime of x2 are. So now, in place of the x2 that we see everywhere in here, we're going to put in the value that we computed previously. So each time when we run the algorithm, we compute a number, and then that's the value that gets plugged in to get the next number. So plugging that in, we get an expression that looks like this, and then we work all that out, and we get about 0.65292. Now that's the answer we're looking for. We've performed two iterations to get us to the value of x3. Now I might suggest that you try computing one more iteration. And it's kind of interesting to note that you would actually get the same answer. You would get x4 is equal to 0.65292. I've already done it, and you should probably try the same thing. So that tells us there's a pretty good chance that within 5 decimal places, this approximation is accurate. So what we've gotten just with two iterations is a very good approximation for the answer, the actual root of the equation. Okay, that's all for now.